rated values of electrical appliances. What is rated value? Every electrical appliance has its designed voltage and designed working power, which we call it the rated value. So you can see here there is a label of a fan heater. It writes clearly that what is its working voltage and the expected power. We can consider it as a designed voltage, and when we applied the voltage which is same as the rating voltage, it will give out the rating power. So let's consider the diagrams below. In the middle one, okay, if we provide the voltage is same as the rated value, then the power if given out is same as the rated value also. However, if we provide a smaller voltage to it, then it won't able to give out the same power. It will give out less. If it is a light bulb, it may be dimmer. If we give an extra voltage for it, then its output power will be higher. If it is a light bulb, it will become brighter. So once again, the applied voltage is smaller than the rated voltage. The power output will be less than the rated power. In reverse, then the power output will be greater. If the voltage is too high, it may become overheated and even burnt. How about the rated current of the electrical appliances? If the electrical appliance is working under the rated condition, it will work as its rated current. So by P equals to IV, we can calculate the rated current in this situation. Similarly, we can also derive its resistance by using P equals to V squared over R. This is very useful if the item is not working at its rated value. Let's take examples here. We can see that the light bulb had its rated power and voltage. However, it is connected to a power supply which is smaller than its rated value. So you should note that the rated value is actually just a label only. But this label helps us to find out something. Is that the actual power. Like in part A, we have got the voltage across the light bulb already, but because it is not at the weighted value, so we have to derive the resistance first. So you can just see the step here by using P equals to V squared over R to derive the resistance. And then we can use that resistance and the voltage across to find out the actual power output. Once we have the resistance, we can also use V equals to IR to find out the actual current passing through it by using its resistance and the potential difference. So you can see that it should not be equal to the rated current because we can use P equal to IV to find the rated current, and we will expect that it is different. So this is how we can use the label to do some such kind of the calculation. So in order to explain it, because the actual current is not equal to the rated current, since the voltage across it is actually different from the rated value. So here it is the example about the use of the rated value. Let's take another example here. In example 2, you can see there is a light bulb which have a rated voltage of 8V and a rated power. But we have to be very conscious about whether it is really working at a rated value. In part A, it states that the light bulb is give out the normal brightness. That means it is working at the rated value. That means there should be 8 volts across it. In order to find the resistance of the rheostat, because we know the voltage across the light bulb, so we can just simply use 12 minus x in order to find the voltage across the rheostat. However, we still need to have the current, so we can use the rated current to find it because it is working at the rated value, so it should be working at the rated current also. By V equals to IR, now we can find the resistance of the rheostat in this way. And then the part B is say that the rheostat adjusts to the new value. So now you should know that the light bulb is not working at its normal situation anymore. In this case, we have to first find the resistance of the light bulb by using the rated value as similar to the previous example. So we can use P equals to V squared over R to find out the resistance of it. And the rest is just similar to a common simple circuit question. So by V equals to IR, we can derive the current passing through the light bulb by consider the whole circuit. And then how about the power output? Because we know the current passing through and we also know the resistance of it, then we can use P equals to I squared R in order to find out the power output of the light bulb.